Welcome to another physics class. In our last lesson, our topic was Newton's second law of motion. And when we ended on that day, I promised that today we are going to force, mass, and acceleration of a body under Newton's second law of motion. But before we proceed today, let's quickly remind ourselves what meant by Newton's second law of motion. By then, I said the Newton's second law of motion states that the rate of change of momentum of a body is directly proportional to the force applied. Mathematically, we said Newton's second law of motion states that F is directly proportional to delta P. Mind you, where the delta P is change in momentum, then over time. That is, the rate of change of momentum is directly proportional to the force applied. The word rate, time is inclusive. So that is F is directly proportional to delta P over T. Where this our F, where F is force, delta P is change in momentum, and T is time taken. Now from the expression, we can now say that F is equal to K delta P over T. Mind you, where K is a constant. If K is a constant and the value is equal to 1, then we are going to have F is equal to delta P over T. And our delta P, but delta P is equal to, that is change in momentum. That will be final momentum minus initial momentum. If that is the case, then the final momentum will be equal to mv minus mu, final minus initial. So mass is constant. So we now say delta P be equal to m minus into bracket v minus u. Now from there you can now say F will be equal to m into v minus u over t. And by then, from linear motion, we said v minus u over t is linear acceleration A. Therefore, we can now say F is equal to ma. That is from Newton's second law of motion. Now, from this equation now, we can now say that the acceleration of a body is directly proportional to the force applied to the body. At the same time, the acceleration is inversely proportional to the mass of the body. That's what I will say in essence is that A will be equal to F over M. So we can deduce from this formula now. 1. A is directly proportional to F. That is, as you increase the force applied to a body, then the acceleration also is increased. At the same time, 2, A is inversely proportional to M. So therefore, the mass of a body will determine the rate at which it will accelerate. If a body have a larger mass, then it will have a smaller acceleration. And if a body have a smaller mass, it will have a larger acceleration. From one above, it implies that acceleration A is directly proportional to force applied. Why from 2? It implies that acceleration is inversely proportional to mass of the body. To illustrate the two statements on the board, let's view the picture on the screen. Now, from the first picture on the screen, you can see the man pushing the wardrobe with larger mass. The fact that the wardrobe had a larger mass, the force produced by the man had no effect to the extent that it produced no acceleration. That is, according to what we have said on the board, A is inversely proportional to mass. So since mass is greater than force, then there is no acceleration produced. Second picture on the screen. Here are two men. One pushing 500 kg, the other pushing 50 kg. Now, according to the statement, the man pushing 500 kg will need to apply greater force. But the man pushing 50 kg will only use a small force for the 50 kg to accelerate. Therefore, if you compare the acceleration of both men, then the man pushing 50 kg will be accelerate faster than the man pushing 500 kg due to the mass of the two bodies. Let's look at the third picture on the screen. So also we have two men pushing two bodies with different masses. But if you look at it, the force produced F1 is equal to M1A. That is, force is the product of mass and the acceleration. And the second man, call it M2. Now, the force produced is F2. Now, that one will now be F2 is equal to M2A. But you look at this second man now, the mass push is greater than the first man. Now, it means M2 is greater than M1. It implies that the force of the second man, F2, will be greater than F1. And compare the acceleration. The fact that the first man having F1, M1, and A, that is, F1 is equal to M1A, and the force produced by it is smaller than that of the F2. The acceleration, depending on the mass of each body that they push, will be dependent by that mass, that is M1 and M2. Now let's look at the third picture on the screen. This one consists of three men of different masses, pushing different masses with the same force. The mass for the first man is M, while the mass for the second man is half M, and the mass for the third person is 2M. If you are now compare their acceleration, the man with mass M have A acceleration, the man with half M have 2 acceleration, and the man with 2 mass have 1/2 acceleration. Why is it that the acceleration is varied? It's due to the value of their mass. the man with the smallest mass, which is half mass, that is half m, have two acceleration, which is the greatest acceleration within the three, followed by the man with the mass m, which have a acceleration, and the man with the largest mass, which is 2m, have the smallest acceleration. That is to say, force is directly proportional to mass, or force is the product of mass and the acceleration produced by a body, according to what we've explained on the board. Now, from the equation on the board, that is F is equal to ma, the Newton's second law of motion is also known as law of momentum or law of acceleration. That is Newton's second law of motion. Newton's second law of motion is also known as law of momentum or law of acceleration, which states that the acceleration produced by a body is directly proportional to the force applied and inversely proportional to the mass of the body. That is the Newton law, which second Newton law of motion, which we say is also known as Newton law of momentum or law of acceleration, is said that the acceleration produced by a body is directly proportional to the force applied and inversely proportional to the mass of the body, according to the equation given on the board. Now, this is convenient point to stop for today. In our next class, we are going to impulse and momentum. And before then, as I always say, if you are just joining us for today, please try to like, share, and subscribe. So when I post a new video like this, you will be able to get the notification in time. Thank you.